Welcome back to Oil and Gas Insights. If you are new here, make sure to subscribe and hit that bell icon so you do not miss any of our deep dive into hazard methodology. Did you know that most process hazards are hidden until systematic analysis uncovers them? Do you people know that most process hazards are hidden until a systematic analysis uncovers them? Today we are moving forward to the next essential concept in hazard deviation analysis. By the end of this video, you will understand what deviation are, how they are identified, and why they are the key to unlock hidden hazards in your discussion. Stick around because we will also walk through a real world example of deviation analysis on distillation column. Let's dive in. Let's start with the basics of context of hazard. A deviation is any departure from design intent of a process, especially it's when happens when the system does not operate as it's supposed to. And deviation are identified by combining parameter with guide words. For example, no flow. A deviation indicates that absence of flow in a pipeline. More pressure. A deviation suggests higher than normal pressure in a vessel. Reverse flow. A deviation describing fluid moving opposite direction. Deviation helps you pinpoint where things could go wrong and assess their impact on safety, quality, and operation. Deviation analysis is crucial because it translates the abstract application of guide words into actionable insights about your process. Here's why it matters. Hazard identification highlights specific risk tied to process deviation. Next is risk assessment. Evaluate the consequences of deviation such as equipment damage or safety risk. Next is proactive safeguards. Informs that development of control measures to prevent or mitigate issues before they arise. Here's how to perform a deviation analysis step by step. First, define the design intent. Understand the intended operation of a system. For example, a distillation column separate component based on boiling point under control condition. It's its basic purpose of distillation column. Next is selecting parameters and applying guide words. Identifying the key parameters and applying guide words. For example, parameter pressure. No pressure indicates a vacuum condition, could lead to equipment collapse. More pressure could cause overpressure and trigger a safety valve. Analyze potential causes. What could cause this deviation? For example, reverse flow might result from a failed check valve. Assessing consequences. What happens if deviation occurs? No flow to a reactor could cause overheating. Proposed safeguards. What are the proposed safeguards? Identifying the safeguards like pressure relief valves for overpressure or low flow alarms. Deviation analysis can be challenging. Here are some common pitfalls to avoid. Number one, incomplete parameter list. Missing startup or shutdown scenarios. Next is vague consequences. Failing to the detail of full impact. Next one is overlooking safeguard. Ignoring existing control or missing the robust solution. Let's apply what we have learned to distillation column. Consider these deviations. First is parameter, and the parameter considering temperature. No temperature condition is no temperature scenario failure leading to inaccurate separation. More temperature scenario, product degradation or safety valve activation. Less temperature scenario, incomplete separation and off-spec product. Next parameter is flow. No flow, pump failure causing imbalance. Reverse flow, failed valve contaminating the feed stream. Let's quickly recap what we have learned today. A deviation is any departure from the intended design of a process. Combining parameter and guide words helps identifying deviation. Deviation analysis aids in hazard identification, risk assessment and safeguards. Following a systematic approach helps uncover hidden risk. Thank you for watching. If you found this video insightful, do not forget to like, share and subscribe to Oil and Gas Insights. Hit the bell icon so you are notified about our upcoming videos. Next time we will cover human factor in hazard studies. If you have any question or topic, drop them in the comment below. Until next time, stay safe and keep learning.